Okay, let's get started. So we have a few more problems involving tangent lines in this section 1 still. And so you notice most people probably see a circle and a triangle, but what you really need to see is this line is tangent, which guarantees us when there's a radii and a tangent line, we're going to have perpendicular lines in there, which is going to produce a right triangle. And as soon as you see a right triangle, ding, 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 we can use Pythagoras, trig, anything we want. Another thing that we should notice here is the length of this little blue line right there. For some reason, a lot of students have trouble seeing the length of that blue line. Well, if you notice, this blue line is 3, and then you have to ask yourself, how are these two lines related to one another? Well, if this one's 3 and it's actually the radius, this one has to be 3 because it's the radius as well. So in this case, the goal here is to find x, and I'm just going to redraw this picture. And when I redraw it, I'm going to make this a 3 over here. This is length 10. Notice the hypotenuse is not 21. Don't be multiplying these two together. This is 3 plus 7, that's 10. And then x is on the bottom here. So this is not a nice family member shortcut in here, a triple I should say. This is probably going to be some sort of radical, so I'm going to say x squared plus 3 squared equals 10 squared. This is x squared equals, well, 100 minus 9 is 91, so x turns out to be the square root of 91. And I don't think that's I think that's simplified the square root of 91, so we're going to leave it just like that. Let's try another problem. Here's another problem, and again, most people see a circle and a triangle, but what you need to see is a tangent line. Not only do we have a tangent line, we have a radius and a tangent line. Your brain has to see that produces a right triangle. And once again, as soon as we have right triangles, we can use trig, we can use Pythagoras, we have so many options. So once again, if you notice that this length is 9, you have to come to the conclusion that that length is 9 because that's also a radius. So in this case, how do we solve for x in here? Well, it's still going to be Pythagoras. What do we have? We have 12 squared plus 9 squared equals the quantity. What is this longer quantity right here? Well, it's not 9x. You got to say it's x plus 9, and then we always square it. So let's say this is 144 plus 81, and when you FOIL this turns out to be x squared plus 18x plus 81. So we're going to try to solve for this now. What do we have? Well, I do notice there's 81s on both sides. They can just cancel right away. And this one's a little tough to solve for. Why? Is because this is what we call a quadratic term. This is what we call a linear term. And that's what we call a constant term. And when we see a quadratic, what we like to do is we like to move everything onto the same side. So I'm going to keep the x squared and the 18x right there, but I'm going to bring the constant onto this side. This goes back to an Algebra 1 skill from a long time ago. We've got to try to learn how to factor this. And so basically, I'm going to take out my calculator and start thinking about factors of negative 144 that add up to be 18. So just give me a moment here. So I'm going to take 144 and start dividing it by some numbers. And I think 24 times 6 is going to be the key here. Well, 24 times 6 is 144, but I want it to be negative 144. That implies that one of these two numbers right here has to be positive and the other one has to be negative. But when I add them together, I want a positive 18. So that tells me if I make the 24 positive and the 6 negative, that gives me the balance here between 24 times negative 6 is 144. But when I add them together, I get a positive 18. And so that turns out to be the factors in here. So when you learned how to factor a very long time ago, this turns out to be x plus 24 and x minus 6. And at this point in algebra, the problem actually stops and starts again with two new assumptions. We assume that this one has to be 0 and this one has to be 0. So when we solve for this, it looks like x is turning out to be a negative 24. And keep in mind, this is an algebra solution, but in the context of geometry, we can't have a negative side, so we are not going to use negative 24. In the context of this problem here, x turns out to be a positive 6, and that's good because we want that number to be positive. Therefore, x is guaranteed to be 6. That's the only solution here. Now, once again, this is a tough, the geometry here is relatively simple, but 90% of the work in here really went back to understanding how to factor and how to solve for some quadratics in Algebra 1. All right, let's try to take a look at another one. I love this picture here. These are two circles. One is a larger circle with radius 12. That's really important to kind of see. And another one is a little bit smaller with radius 9. And in this problem, the goal is to find this length between the two centers of O and P. And to do this, we have to be very creative enough to draw in an extra line. Because if you notice here, this shape is not a triangle, it's a quadrilateral. Okay, so quadrilaterals are nice, but we like right triangles. Right triangles turn out to be very good friends of ours. And so you notice there's already a right triangle in here. And in this picture, this is a tangent line and a radius. This one's a right angle as well. So where am I going to draw my extra line in? Well, what I'm going to try to do here is I'm going to try to create a line that's parallel to this one, but I'm going to try to start to draw it right here. So I'm trying to draw an extra line in that's parallel to the red one. And if I do that, I'm kind of making a rectangle in here. So not only am I making a rectangle in here, I'm also making a right triangle in there. That little sliver of a right triangle, hopefully you can see that. I'm going to try to magnify it right here. That's x, that's what we're trying to find. And if you notice, if this red line is 25, the dashed red line is this one right here. That one has to be 25 because properties of rectangles, both pairs of opposite sides are congruent. And the problem is trying to discover what this little red line is over here. Well, if you notice, if this length is 9 over here, then this line in here has to be 9 as well because it's a rectangle. The sides are, the opposite sides are congruent. Well, if the whole thing is 12 and this part is 9, then this implies that that part is 3. So now we're good to go. Look at this. We have a triangle. Not only do we have a triangle, we have a right triangle. And I can have set up Pythagoras in here. 3 squared plus 25 squared equals x squared. So let's see, what is that? 25 squared is 625. And I add that to 3 squared, which is 9. That's going to be 634. That equals x squared. And that is the square root of 634. If I give it a little twirl right now to try to simplify that, I don't think this one can be simplified. I'm kind of dividing with my calculator right now, trying to see if we have factors of 634 that are perfect squares, and I can't find one right now. So that is the solution for this one. This one's pretty intense. We're going to do one just like this, but a little bit different, and to kind of finish up here. So let's try this one. It almost looks like the same picture, but notice in the previous picture, this was our x, and that was the 25. So in this case, they're opposite. So we're trying to find this value, and this one we already know is 7. So once again, I see a tangent line and a radius, that's perpendicular. A tangent line and a radius, that's perpendicular. And I'm going to draw this auxiliary line in. Auxiliary lines are extra lines we draw in geometry to kind of help us creatively solve some problems. And notice I'm forcing it to be a rectangle. I'm forcing this black line to be parallel to that black line right there. And so notice if that's x, now that's x. And if this blue line is 2, this blue line is 2, implying if the whole radius is 3, this side has to be 1. So if I redraw that little sliver of a triangle, this is 1, that's x, that's 7. I can now use Pythagoras. 1 squared plus x squared equals 49. Oops, yeah, 49. 7 squared is 49. And if I square the 1 and bring it on the other side, that's x equals 48, and x is the square root of 48. Now this radical can be simplified. Why? It's because I know my factors of 16. 16 times 3 equals 48. So therefore the answer is 4 radical 3. That is the value for x. All right. So as you can see in the last couple problems, the intensity went up with some algebra. Make sure you're locking in the algebra, the drawing in extra lines, the geometry of the relationships between tangent lines and radii, and trying to connect all what we know about geometry to kind of solve these more difficult problems.